All right. Good evening, class. Welcome in our today's lesson. This is suffering, and I'm gonna deal with you. I hope everyone can see.
No.
I hope everyone can see. Let's go to our pages. In our today's lesson, we're gonna deal with the subject. The topics that we are dealing with. The first topic, which is called right. So we are dealing with the topic called electronics. And in this subject, to the concrete topic that is started there, which is current. The topic of current is something very interesting there. And from the topic of current, we learned something called the electron. We have something called electron and a topic called electronics. Even though also in the topic called physics, you are also going to learn what we call electron. So, what is the origin of it? Why do you need to take this topic? It's because in this subject called electronics, we're gonna be also with this one. So this is to say, these two subjects, which is electronics, are even closely related to each other. We can see the subject very clear, and there are some subjects which I'm going to analyze, which we can start. The first subtopic is the concept of electronics. The concept of electronics. So the first subtopic is the concept of electronics. This word electronics, the word electronics originates from the word electron. So electronics originates from the word electronics. Electronics originate from the word electron. But to some of you, may be asking yourself, what is the term electron? Or rather, what is the meaning of the term electron? Now, in order for you to understand the meaning of the term electron, let us go back from the concept, or rather from the subject called atomic physics, or physics of the atom. Whenever we are dealing with the physics of the atom, we are dealing with something atom. So, what is atom? There are various ideas evolved by different scientists about what I want to catch is atom we are dealing with the smallest indivisible part of a matter. So whenever we are dealing with atom, we are dealing with the smallest indivisible visible particle. open. So simply, we are dealing with the smallest individual particle vector. The smallest individual particle of a. Now, in order for you to understand this, at least we need to talk about the concept that everything in the universe, we almost consider everything as a matter. For example, you can take a stone, we can take various objects. They are considered as matter. So let us assume if this is a stone now. Assume this is a stone. If this is a stone, the field there, this is called the kinetic field of matter, which is one of the fields that you learn in the topic called the properties of matter, which is the Form 1. So according to kinetic field of matter, all matter, including solid, liquid, and gases, they are made up of small subatomic particles. They are made up of small subatomic particles which are in constant random motion. This is according to kinetic theory of matter, which is Form 1 topic that you learned there from the part, which is properties of matter. So according to this theory now, which is kinetic theory of matter, it says all matter are made up of small particles that are in constant random motion. Why am I trying to revise this? I want you to get the concept electron. And to understand the electron, you go to understand atom. To understand atom, you go to understand matter. And to understand matter, we go to take an example of stone, which is an example of solid matter. So stone is a solid matter. And because the stone is a solid matter, according to kinetic theory of matter, it is made up of small atomic particles. According to this theory, these particles are in a constant random motion. That means they are moving with a speed. So now, assume if you have a hammer. Now you want to break down this piece of stone. So you want to break this one. Again, you can break also another piece of stone. So after you break a piece of stone, you're going to have a small stone. Now, what happens if you continue to break down those small pieces of stone? If you continue to break down the small pieces of stone, you're going to have a very, very small particle. Now, continue to break a very small. After you continue to cut down or break down these small particles, you're going to have a very, very small, fine subatomic particle. So you will reach a certain point where you will have a very, very small particles. These particles will not be further divisible. So the particle cannot be further broken down. So what happens now? These particles not be broken down anymore. There is no way how you can break down anymore. What we call now, just in few years back, years like 1890, we had divided scientists like Rutherford, scientists like Thomson, J.J. Models, and also we had scientists like tried to add the structure of atom. And this is why they went further to conclude that atom is made up of a dense or rather the center of the core, we have the core of the structure here, and this is structure is named as and according to this scientist, this subject is of the atom, but I'm trying to so that everyone can understand what is electron. So at the center, that is where you have proton and at the center you have proton and neutron. Where proton are positive charge and electron is have no charge. They are taken as zero charge. So according to this scientist, they argue that electron evolved around the nucleus in a circular path called orbit. So this happened. and the electron revolve around. And the electron were taken to be a negative charge. So these are so at least from this subject, everyone is aware now of the subject where electron is taken. So in this subject of the electronics comes from the root electron. So what I was trying to do here is to explain electron, the origin of electron, the general concept of electron. Now, since we know for sure that our subject is electronics, in the concept of electronics, we are dealing with electron. So now, what are the important or best ideas that we are dealing with? How do we deal with the electron? So in this subject, let us see which aspect do we cover in this subject today. After we know now for sure what is electron and what is the origin of electron, let us now dive into the subject, which is electron. Specifically, this is the concept. So in this subject of electronics, we're going to deal with the following aspect covered. And what is electronics generally? As I told you, because the word electronics originates from the meaning electron. Now, what are we dealing with in this subject, which is electronics? In the subject of electronics, we are dealing with flow of electron, or rather, number one, we are dealing with behavior of electron. Also, in electronics, we are dealing with behavior of electron. But also, in electronics, we are dealing with properties of electron.
Yes, continue. Yes, continue, sir.
All right. In electronics, we are dealing with behavior of electron, we have emission of electron, but also we have properties of electron. Also, we are dealing with how electron is formed. But we are dealing with the behavior, emission of electron, properties of electron, and the how electron flows in which material. So there are material in which electron flows from one point to another. So we are dealing with simply and electronics as So someone can define an of flow of any devices like semiconductors and the vacuum tubes. That means in electronics, we go to deal also devices in which electron flows. These devices we are dealing with devices, but also we are dealing with vacuum tubes. So these are few examples on which electron can flow from one point to another. And in the topic of current electricity, you learn the length of flow of electrons in materials like the length of flow of electrons in materials. It was the subject called. So you did there with the electric current, which is the length of flow of electron in conductor. Conductors we have materials to pass through. Materials that allows current to pass through, allows charges to pass through. Current electricity. But in this subject, electronics, we are dealing also with flow of electron as already there in the current electricity. But subject now, we are dealing with flow of electron, we are dealing with flow of electron in semiconductors and vacuum tubes. So this is a primary idea about it. But some can ask the difference between electronics and current electricity. Let's respond to this question. All right, so if there is any question, any misunderstanding, go to us.
Angalia muonekano kule. Kwa namna wanacheza wenyewe. Zima mic, zima mic.
Right, so let us try to respond to this question. So the question is, what is the difference between electronics and current electricity? You may be asked to respond to this. In current electricity, also the flow of electrons. But also, we are coming with we are also dealing with the flow of electrons. Now, what is the main difference? Let us dive now. So here is how we respond to this. Hello, student. How do you understand this question? What is the difference between electricity deals with the flow of electron in conductors? In electronics, we are the flow of electrons in semiconductors. So we have flow of electrons in osmoon, we have flow of electrons. Someone may be asking again, what is conductor and what is conductors are those materials that allow charge to play. Materials these are materials that allow charge to flow. But also, we have material like insulin.
Zimeni maiki.
Anasema mzima maiki. Yeah.
Utaendelea mwalimu mtu kidogo.
Iko mbona mambo yako?
Continue. The teacher is coming right now. Mwalimu ametoka kwa anakuja. Anakuja kuzima.
Wait here.
Endelea kisha tuachue mziki.
Kwa mwalimu anashindwa kuendelea kwa sababu sauti yenu ina interfere. Sasa tunakuwa tunasikia makelele yenu.
Yes, continue. Tumeachia.
I get you. Okay, so insulator. These are materials that allow current to enter. For example, wood. They are but if you're not something in electronics, we are dealing with semiconductor, which is none than conductor, none than insulator. So we got now to learn what are semiconductors. So semiconductors, simply we are dealing with materials that conductivity lies between insulator and that of conductor. That means semiconductors are materials which are either, or rather their conductivity lies between conductor and that of insulator. They are termed as semiconductor. The word semi means a half. So this is to say semiconductors are materials which are half conductor and also a half they are insulator. That means at some extent, semiconductor, they can conduct electricity under certain condition, and also they cannot allow current to pass depending on the condition. So I was trying to revise this concept of conductor, insulator, and the semiconductor. Conductors, remember, they allow current to pass through. For example, wires like copper, insulator, and the others. And aluminum, they are termed as conductor. But insulator, they do not allow at all current to pass through. But semiconductor now, which is our subject today, is a material that conductivity lies between insulator and the conductor. So in our subject now, which is electronics, we are dealing with the flow of electron, but in the semiconductors. And remember, semiconductors are materials in which their conductivity lies between that of conductor and that of insulator. That means they are somewhere in the middle there. They can be used as conductor in some instances, and also they can be used as insulator depending on the condition. So now, class, this is a main difference between electronics and the current electricity that you learned there when you were a Form 3 student. Now, let us dive and see how is electronics widely used in our daily life. What are the applications of electronics in our daily life? Almost all aspects, or depending on the use, or rather we say electronics is a widely and it is a fundamental subject specifically in our daily life. It covers almost all aspects. Let us see now the aspect on which electronics cover. So we have application of electronics. In this part, we want to learn how is electronics applied in our daily life. Where can we apply electronics in our daily life? Number one, we apply electronics in what we call consumer electronics. Consumer electronics, we are dealing with all devices. Some of them, they are used in offices, and some of them, they are used in various places, even at home. We have various electronic gadgets. So different electronic gadgets. Different electronics gadgets used in offices and the other places, whether it is a school, home, whatever. Most of them, they are made up of electronic components. they are made up of electronic components. We have what we call electronic components. And just in a few minutes, we're going to deal with electronic components. But all these devices that are used in the offices, some of them at home, and the others in the schools, in laboratories, in the hospital, most of them, they are made up of electronic components. For example of these devices, we have devices like calculators. We have devices like printers. We have devices like cameras. We have devices like fax machine. We have also devices like digital versatile disk. DVD. And also we have devices like scanners. A lot of them. We are dealing with most of the electronic devices, most of them. They are made up of electronic components. So this is application number 1, which is consumer electronics. In consumer electronics, we are dealing with all devices that we are using, some of them at home, at school, in the offices, most of them. All these devices like printers, cameras, fax machine, DVD, scanners, and the others, they are all made up of electronic components. That means without electronic components, it is impossible to have these devices. And you know how widely these devices are used, especially in our daily life. Now, this is our first application. Let us head to the second application, which is the second one is electronic automation in manufacturing industries. Electronic automation in manufacturing industries. That if we consider in manufacturing industries, we have various product and goods that are processed there, and then they are converted into raw materials that we are using in various places. But in order to facilitate all this process to convert these raw materials into the finished product, we go to use automation machining. So in industries where we are trying to rather process all these raw materials into finished product, we go to use we have what we call automation machines. In some extent, in the manufacturing industry, there are some tasks which are subjected to machining. Why? Is because it is very dangerous for human being to perform such tasks. So, machine is preferred as the best option to perform this task, which to human being, they can be dangerous. So, machine performs well this task, but all this automation machining, they are made up of electronic components. Automation machines that are used in manufacturing industry to process various products or various raw materials into finished goods and products, they are made up of electronic components. So this automation machine are made up of electronic components. So they are made up of electronic components. And remember, this automation machining are preferred to be used due to their high efficiency and quality of performance. They can operate in a high rate as compared to human being. That's why just in a few years to come, in the modern technology, almost everything is assumed and some is predicted to be covered by these machines. Why? Is because they perform tasks in a given time, and also they are highly efficient. So all these machines, they are made up of electronic components. This is the second application where electronics is applied. And so you can see now how electronics is important, that if we do not have all this automation machine, there are some works which will be very difficult. Why? Is because there are some tasks and work which are dangerous for you to perform. So there is no way out you can perform those tasks without having this machining. So you cannot have this machining without having electronic components. So this is to say, electronic components is very paramount, is very important when it comes to the manufacturing industries. Let us see now application number 3. Also, they are used in telecommunication. Electronics is widely used in telecommunication. And the word telecommunication, what is telecommunication? Telecommunication, we are dealing with the distant communication, far away communication, and hence the word tele. The word tele means far away or distant. The word tele means distant or far. So this is a communication from far away. For example, you want to communicate with somebody from China, Germany, and the other countries. This is a far communication. So how can you communicate with these people from far away? So this is where now, in modern technology, we go to have smartphones. We have got devices like smartphones. We have computers that can be used to communicate with somebody from far away. That's the meaning of telecommunication. So if you want to communicate with somebody from far away, we have got now smartphone, we have computers, and you can use all these devices to communicate with somebody from far away. And even now, it is very, very common that you can even see someone from far away by using WhatsApp, through video calls. You can communicate with somebody from far away. So this is one of the application of electronics in telecommunication, where these devices like smartphone, computers, they are all made up by electronic components. So they are made up of electronic components. They are made up of electronic components.